Hey guys, I hope you are all doing well. Welcome to my channel Beloved Academy.
In today's video, we are going to be learning how to differentiate using the product rule. When do we use product rule of differentiation? When we are given a function whereby there are two parts which are multiplying each other. Thereby, we employ the principle of the product rule to differentiate such function. For example, let's assume that we are given y is equals to uv. U is a part of this function and v is also the part of this function. The sign between u and v is product. That is why we employ product rule in this place. Product rule states that when we are told to differentiate a function in which the two parts are multiplying each other, we are going to have dy all over dx is equals to u dv dx plus v du over dx. Now, this is what product look like. When we are told to differentiate a function which has two parts, and these two parts are multiplying each other, we are going to be using the product rule. Don't forget, in my previous video, I show you how to differentiate using the first principle and using the power rule of differentiation. Probably you didn't know how to differentiate using the power rule of differentiation. You can go back to the channel and watch the video that I dropped on how to differentiate using the power rule. Okay, let's use product rule to solve a question. Let's assume that we are given y is equals to 3x minus 2 into bracket, open bracket, x squared plus 3. How do we find the differentiation of this function using the power rule? The first thing to do is to identify your u and v. Don't forget that from the product rule formula, we have u dv over dx multiplied by v du over dx. Now look at this question. We have y equals to uv and we have y equals to this multiplied by this. Comparing this with this, you can realize that u is equals to 3x minus 2, 3x minus 2, and v is equals to x squared plus 3. Now you can see that I have identified my u and v. The next thing is to go back to the formula. You see that you need dv over dx, and this is your v. Using the power rule of differentiation, you can proceed and say dv all over dx is equals to 2x raised to the power of 1, which is 2. Differentiate a constant will give 0, so there is no need of writing that. You have find your dv over dx. Now let us proceed to the second side of the formula. We have u equals to 3x minus 2. In this case, I need the differentiation of my u, which is du with respect to x. So I have du all over dx in this place. If I want to differentiate 3x, I will have 3. Differentiate a constant will give 0. Therefore, I have all the components of this formula. My u is here, and my v is here. My dv over dx is here, and my du over dx is here. The next thing is to substitute all the parameters inside the formula. Now look at this. Dy over dx is equals to u. My u is 3x minus 2, so I'm going to have 3x minus 2. Let me put that one in the bracket. Open another bracket now. Dv all over dx, my dv all over dx is 2x, so I'm going to have another 2x here. Then look at the sign. This additional sign will come down here, so I'm going to have plus. I have v again, so I will go to the parameters that I have. V is x squared plus 3, so I'm going to be having x squared plus 3 multiplied by du all over dx. The du over dx is 3. So this is, now I have substituted all the parameters that I have into this formula. The next one is to open the bracket. So I'm going to have dy all over dx is equals to 2x multiplied by 3x. I'm going to have 6x squared minus 2 multiplied by 2x, that is minus 4x, plus 3 multiplied by x squared, so that is 3x squared. 3 multiplied by 3, that is plus 3. Now let us proceed to open the bracket if there is anything that we can collect like terms. Now let us proceed. Dy all over dx is equals to 6x squared plus 3x squared, 6x squared plus 3x squared minus 4x plus 3. Dy all over dx is equals to 6x squared plus 3x squared, that is 9x squared. So I'm going to have 9x squared in this place minus 4x plus 3. You can see that I've already found the differential equation, the differential form of y equals to 3x minus 2 into bracket x squared plus 3 using the product rule. That is how we go about it. Now let us proceed to the next question. We have another question here. Y is equals to 3x squared plus 5 into bracket x raised to the power of 3 plus 4. How do we differentiate all this? Using the product rule. Don't forget, the first thing is to identify your u and v. If you compare this equation with what we have here, you can see that u is equals to 3x squared plus 5. So I'm going to write it here. U is equals to 3x squared plus 5. Now let's identify our phi. V is equals to x raised to the power of 3, x raised to the power of 3 plus 4. Now, after identifying your u and v, you look at your formula, which is the product rule formula. We have u dv over dx plus v du all over dx. You have identified your u. You have identified your phi. The next thing is to find the differential form of v, which is dv over dx. Now, using the power rule of differentiation, let us differentiate v with respect to x. So let us have dv all over dx is equals to 3x raised to the power of 2, differentiate a constant, we give 0. So let us find the u all over dx. The u over dx is equals to differentiate 3x squared, we are going to have 6x. Differentiate a constant, the constant is going to turn to 0. So we have known the u, we have known the v, we have known the u over dx, and we have known the v over dx. The next thing is to substitute all this into the product rule formula. U is equals to 3x squared plus 5. So I'm going to be having dy all over dx is equals to, what is u? U equals to 3x squared plus 5. Let me put that into brackets. Dv all over dx, this is dv over dx, which is 3x squared. So I'm going to have 3x squared, this addition sign, plus v is equals to x raised to the power of 3. Let me put a larger bracket here, a larger bracket. So v is equals to x raised to the power of 3 plus 4. Then in my next parameter, I have du all over dx. So du over dx is 6x multiplied by 6x. So I'm going to have dy all over dx is equals to 3x squared multiplied by 3x squared. That is 9x raised to the power of 4 plus 3x squared multiplied by 5. That is 15x squared plus 15x squared. This plus sign. Then we have 6x multiplied by x raised to the power of 3. That is 6x raised to the power of 4. 6x raised to the power of 4 plus 6x multiplied by 4. That is 24x. 24x. So let us look if we can collect like terms. Now we have, I think we have the power 4 here. We have another power 4 here. So we can add this and this together. So dy dx, dy all over dx is equals to 9x raised to the power of 4 plus 6x raised to the power of 4. That is 15x raised to the power of 4. 15x raised to the power of 4 plus, there is no element with the same power again, so I'm going to have 15x squared plus 24x. So I have easily differentiate y equals to 3x squared plus 5 into bracket x raised to the power of 3 plus 4 using the product rule. Have you seen that the product rule of differentiation is very, very simple? Now let us proceed to question number 3. Question number 3, we have y equals to 2x squared plus 4x multiplied by 5x squared minus 2. Now don't forget our step. The first thing is to identify the u and v. Now comparing this question with comparing this function with this function, I'm going to have u is equals to 2x squared plus 4x, while v is equals to 5x squared minus 2. The u all over the x, because this is required in the parameters of my formula. So the u over the x is equals to 4x plus 4, while the v all over the x is equals to 10x. After finding the differential form of u and v, we have completed it. Just one step, we have to substitute this into this product rule formula. So we have the y all over the x is equals to u, which is this, 2x, let me put big bracket, 2x squared, 2x squared plus 4x, all into bracket, u, the v all over the x. So the v all over the x is 10x. So multiply by 10x, this additional sign, plus, close this bracket. Now, plus v, what's my v? The v is 5x squared. 5x squared minus 2. The u all over the x, is 2x squared. Oh, sorry. The u all over the x is 4x plus 4. So, in this case, I'm going to have another bracket, 4x plus 4. Now, I have y, the y over the x is equals to 10x multiplied by 2x squared. That is 20x raised to the power of 3. 20x cubed plus 4x multiplied by 10x. That is 40x squared. 40x squared plus, now I want to pay attention here. We have to multiply. If we want to open this bracket, we have to use every element to multiply every element in bracket A to multiply every element in bracket B. Now let us start by using 5x squared. Let me put another bracket here. So 5x squared multiplied by 4x. 5x squared multiplied by 4x. Then 5x squared multiplied by 4. Then I'm going to have this minus 2 multiplied by 4x. This same minus 2 multiplied by 4. Now, 5x squared multiplied by 4x, that is 20x. Oh, let me clean this. Okay, 20x raised to the power of 3. Now, 5x squared multiplied by 4, that is 20x raised to the power of 2 plus 20x raised to the power of 2. Now, let us proceed. You see, minus 2 multiplied by 4. Minus 2 multiplied by 4, that is minus 8x. Minus 8x. Minus 2 multiplied by 4x, that is minus 8x. Minus 2 multiplied by plus 4, that is minus 8. So, here I'm going to have minus 8 all into bracket. Now, dy all over the x is equals to 20x cubed plus 40x squared plus, I have here 20x cubed again, 20x cubed plus 20x squared minus 8x plus 8. Now, let us look at the like terms in this place. We have 20x cubed here, we have another 20x cubed here, so we can add this up together. Dy all over dx is equals to 40x cubed plus 40x squared plus 20x squared, that is 60x squared. 60x squared plus, okay, minus 8x plus 8. Now, this is the differentiation of y equals to 2x squared plus 4x multiplied by 5x squared minus 2. The differential form of this is this. Thank you very much for watching the video. Okay, the totality of what I'm talking about is that when you are given a function that has two parts, and these two parts multiply themselves, if you are told to find this differentiation of this function, you are going to use product rule. And before you can use product rule, after identifying your u and v, you differentiate the u and v and substitute it into the product rule formula. Thank you very much for watching the video.
On this channel, you will find information, concepts explanation, tutorials video with detailed explanation that will assist you in gaining more knowledge and insight. In addition, our channel features past question, solution to questions you are likely to encounter in exam, solution to all past questions. Please kindly subscribe. All questions are solved with simplicity.